Okay. Are we clear with this? OZD? How many OZD do
Yes,
we
Doc.
have? Five. Are we clear on this?
Yes, Doc.
Okay. So how about PCR? Are we clear with PCR? Especially section B and section doc, because at least I can explain to section A and C. But for B and D, I need confirmation if this is clear. How do you get PCR? PCR is peripheral curve radius. So whenever you talk about radius, you're talking about curve, right? So if this is okay, okay. So if this is the contact lens and this is a bicurve, this is the primary base curve and this is the peripheral curve. Okay, so this is the peripheral curve. So this is PCR, which is this is part of a bigger sphere. And this one is from another sphere, which has its own radius. So this is PCR. And how do you compute for PCR? PCR is as simple as base curve plus 1 to point 1 to 2. And then PCW, which is peripheral curve width, so if this is a bicurve, from here to here, this is the width. Okay, so this is PCW. Okay, so in bicurve you have 2 PCW. In tricurve you have 4 PCW. In a multicurve you have 6. Okay, that's why this here, as you can see, bicurve, tricurve, multicurve, right? Are we clear on this? Section B and D specifically. Anyone from B and D? Can you confirm if you're clear with this?
Yes, Doc.
We can move on. All right. Okay. Now, BZ is what we call blending zone. So how do you compute for blending zone? It's just BC plus PCR divided by 2. So do we have um, any questions on this? Because this is going to be part of your midterm exam. Boy and dog, I need to know from you. Because as for section A and section C, we don't have problems with this. Uh, Zach, section B, do you have any questions here? Okay, I need to know if you're already good with this one.
Parang understood naman, Doc.
Understood naman, yeah. How about the SER, the secondary curve radius, which is BC, which is base curve, plus 1 to 1.5. Is this also clear? Where is the secondary curve radius? Now, this is a multicurve. A multicurve. Again, so first curve, this is called PCR. R. Second curve is SCR. Third curve is base curve. Is that clear? Zach?
Just to make sure, so applicable lang tong SCR with tri-curves.
Tricurve, correct. And
Okay, gets.
tricurve and multicurve.
Okay, gets. Thank you, Doc.
Okay? So this is called secondary curve. All right? So far, we're good. Let's give an example later. Let's compute. But for now, let's take all the formula. So SER is BC plus 1 to 1.5. Next, we have SCW. What's SCW? That's your secondary curve width. So in a tricurve, remember tricurve. So this is a bicurve. This is a tricurve. So this is the base curve. This is the secondary curve width. And this is your peripheral curve width. Okay, so this is PCW and this is SCW. Is that clear, Zach? So far, we're clear? Still good? Let me know, because if you're confused, we can clarify. So far, good?
Yes, Doc.
Okay, good. Good. Good to know. Next,
Doc.
we have, yes, go ahead, Rhea.
Sorry. Can you go back to the other slide, Doc?
This one.
Yes, Doc. I think for section D, we only tackled up until PCW. Yeah,
Huh?
PCW.
PCW, okay. So BZ, not yet. Okay. Blending zone. BZ is blending zone. That's your blending zone. Okay. What is a blending zone? As you can see, when you create additional curve, you are creating this sharp transition. So you want to blend it. So you need to blend. So you're blending it. So the blending is your blending zone. Very clear?
Yes, Doc.
Okay, very good. And what's the formula for blending zone? It's BC plus PCR divided by 2. Again, if you would notice, later on, it will get more complicated. But for now, BC plus PCR divided by 2 in bicurve. But if you go further, we will have now the tricurve. That's why SCR and SCW now is, this is getting more complicated because you're creating more curve. So earlier, we only have peripheral curve and base curve. But if you make a tricurve, you're creating a secondary curve. And a secondary curve will also create a secondary curve width from a secondary curve radius. Going back, see the secondary curve radius? It's SCR, Vea, SCR, number 7, is your secondary curve radius. So where is that secondary curve radius? Okay, I'll do that again. So if this is a contact lens, you made it bicurve. This is base curve. This is peripheral curve. So in creation, you can create PCW here and another PCW here. But if we make a tricurve, 1, 2, 3. Okay. Pardon the drawing. You are creating, this is PCW. Actually, this is PCR. The width is PCW. And this is now your SCR, or secondary curve radius. So whenever you use radius, you're talking about curve, right? So this is now your secondary curve radius. that has a secondary curve width. So far, so good? You follow? Thea?
Doc.
Okay. And of course, this one is your base curve. Okay. So having that, you can now compute using the formula. Base curve plus 1.5 is SCR. Copy? Thea? Copy?
Yes, Doc.
Okay. Now we move. We have SCW, which is secondary curve width. The formula is OZD minus OAD divided by 4. So far, we're good. So how does it work? So if you are to check, it says here, you have your OZD, which is, this is actually wrong. SCW, guys, should be OAD minus OZD. Can you correct that? Avea, Zach, correct this one, number 8. Number 8 is OAD minus OZD divided by 4. Because OZD is always smaller than OAD.
Okay,
That's why.
Doc.
Copy?
Yes po.
Okay. Now, PCR in your tricurve is SCR, which is secondary curve radius, plus 1.5 to 2.5. Copy? What is that? Your peripheral curve radius in tricurve is secondary curve radius plus 1.5 to 2.5. How does it look? So this is your peripheral curve radius, and this is your secondary curve radius. Do you follow? Bea? Zach?
Doc.
Copy?
Copy, Doc.
All right, gotcha. So next formula is the blending zone 2. We're already good with blending zone 1, but in tricurve, as you can see here, you have base curve for blending zone 1 for tricurve is base curve plus SCR, secondary curve radius, divided by 2. This is for everyone, even section A and section C. This is blending zone 1 for tricurve. It's base curve plus SCR, which is secondary curve radius, divided by 2. Is this copy? Is this clear?
Yes, Doc.
Okay. Then you have your blending zone 2, which is secondary curve radius plus peripheral curve radius divided by 2. So far, so good. We have all the formulas.
Yes, Doc.
Okay. So as you can see here, this is an example of a bicurve. So if I am to give a value, let's try to compute using these formulas. Okay. Okay, let's start. Let's see if we can do this. Especially boy and dog. Let's do this. If I have a minus 350, let's change it. Let's have 450 combined 1, axis 180. Okay, K readings 46.50 and 45.50. HVID, let's give it at 10.5. Start computing, guys. And give me your answer. just like this. Send your answer just like this, guys. Like, give me bi-curve answer, tri-curve answer, something like that. So use bi-curve and then use tri-curve. Send your answer through the GC, just like this, just like just like this. Like, this is a good example. This one is a good example. So show me how it's done, how you computed for the following. Let's see if we can come up with that. This is bi-curve, and this is for tri-curve. Is that understood, Vea? You are to send your answers, guys.
Hello, Doc. Is it possible to get back to the given?
Okay. 450 combined minus 1, axis 180. K reading. Of course, this is at 180, and this is at 90. HVID, 10.5. Out of this, you can get all. You can have the secondary curve radius, you can have peripheral curve radius, you can have the blending zone 1, blending zone 2, of course, PCR, PCW. You can get everything. Just use the formula. How to derive
Hello, Doc.
Yes, yes, yes.
When solving for OAD, will we be using 2,
This one,
2.5, or 2.25?
this one. Use two.
2
One is
lang,
two.
okay.
Yeah, yeah, yeah. You may use 2.5, but for uniformity, let's use minus two. The only thing that you cannot use is the OZD for PS plus 1 to 2 because I did not give people size.
Hello, Doc. Pwede po balik sa
Yeah,
mga
yeah.
formulas?
Formula. Okay.
Sorry.
No worries, no worries.
Doc, dun sa
For
tri-curve sana.
for the OZD for uniformity, let's use 80%. If you need OCD, like this one, OCD, SCW, read the OCD. So what are you gonna use? Use the 80%.
Doc, for
80%
PCR.
of PCR. PCR is SCR plus 1 to 2.5. This is for tricurve.
So,
It's
1 or 2.5?
let's make use of one.
1. So,
For
for
uniform.
both SCR and PCR, we use 1.
Yeah, sure.
Okay, thank you, Doc.
Okay. Let's use one. Both bicurve and tricurve, let's use one. For OZD, let's make 80% of OAD. As for OAD, it's HBID minus 2. Send your answer here in the chat box. And this is for everyone, guys. Not just for some, but for everyone. What is 6.8, Anissa? Let me know what it is. Indicate. Put there 6.8 is, what is it? Is it your base curve? What is 6.8? OZD, okay. That's the 80%. Okay. Okay. How about the other? How about PCR, PGW, SCR, SCW, BZ1, BZ1 tricurve, BZ2 tricurve. Anissa, your section C. We discussed this already, right? Last Saturday, Anissa.
Ano po, Doc?
We already discussed this formulas, right? Last Saturday. Up to tricurve, blending zone 1 to blending zone 2, right?
Yes po ata, Doc.
Why yata? Okay. What's the answer for the others? Where's your PCR? PCW, SCR, blending zone 1, blending zone 2. Very good, Joyce. Base curve, 7.42. OED at 10.5 minus 2. That should give you 8.5. Very good. OZD is 80%. Very good. It's 6.8. Very good. PCR is 7.42 plus 1.0. PCW 0.85. If you can show me the breakdown, guys, as simple as breaking it like this, just like to show me how you came up with that, similar to this, similar like you came up with a biker which is like divided by 2 equals. Can you give me your breakdown, how you came up with your answers? But very good, very good. Where is the base curve? Where is the for tricurve, for bicurve and tricurve, right? Blending zone 1 and then blending zone 2. Joyce, you still have to do the blending zone 2 using a tricurve. You have a blending zone 1 and blending zone 2 for tricurve. I'll show you the formula again. This is for bicurve, and this is for tricurve. Zach, as long as you have the formula, you can easily compute it, right? Any confusion? Any clarification? Which part are you confused? Which one do you want to clarify? Let me know. For section C and for section A, we'll have another computation this Saturday. On bicurve and tricurve. For section B and D, let me know if you need clarifications so we can address it right now. So you can see in bicurve, Zach, the PCR in bicurve becomes your SCR in tricurve. So don't be confused because we're dealing with two different design. In bicurve, you only have base curve and peripheral curve. You don't have secondary curve. That's why your PCR here is base curve plus one. Unlike in tricurve, your PCR is no longer your base curve plus one because that is now your secondary curve. So the peripheral curve now is SCR plus one because this is in tricurve. Don't be confused. Okay. No, I'll try, but I only competed for the bike curve. All right. Crystal? Zach? All right. All right. Okay, Chester. Gotcha. How about the others? Are we done? Okay. All right. All right. There you go. Very good. Very good, Joyce. Very good, Zach. All right. There you go. Charmaine. Very good. Okay. Any more entry? Okay. You realized the given was 45.50 po pala. I was computing for 45. Okay. All right, Crystal. Gotcha. Okay. No worries. You may try again. Any more entries? This is just the beginning, Zach. We have another. There's more computation. Like using the the fitting guide. This is another computation for the fitting guide. I'm gonna throw it out there. Wow, the thinking, Zach. Hmm. Good one, good one. Any clarifications, Zach? Any questions? Not so far. Everything's good. Yeah, you have As long as you have the formula, you won't get, you know, confused. Okay, let's check that out. Okay, Angela. All right. Very good, very good. Good, good, good. All of these I will check.
Doc, pwedeng magtanong.
Yes, of course.
Doc,
Yes, Zach.
kasi with our soft toric, our principle was using the flatter case for computation, right? Because flatter is better, di ba, Doc?
Yeah. We always fit flatter than flat.
However,
the-
that's for
Pearl.
soft contact lenses, right?
Soft.
Pero here, when we're doing RGP, we're going to take
RGB is the same.
average
The general
as softer
The general rule is always fit
Flat.
flatter than flat.
okay.
But of course, um, when you are fitting, the first thing that you do, of course, is to create a parallel fit. So if you always fit flatter than flat, obviously you need to adjust. That's why, in the rule of thumb, for every change in the base or changing the base curve. So there's two attack. There's two ways to do that, right?
Okay.
It's either you change the base curve or you change the lens diameter. So this is very critical. Unlike soft contact lens, because it's soft and pliable, it conforms to the cornea. So we don't really compute much. We don't really worry about fitting. We don't worry about parallel fitting because automatically it is parallel all the time. But with RGB, because it's hard, we start with flat. We always use flat. Generally, we always use flat. But of course, having that, you have, for example, 45. Okay, this is how it is. I'll show you, Zach.
Sige, Doc.
Okay, why are we fitting on the flatter? It's because of this. Insert page. Okay, I have 90, 180. Okay,
Okay.
choose what do you want to be. Okay, I'll have 44 and a 45.
Okay.
Which one do you want to be flat?
Flatter,
180, 90.
make it 90 is flatter para with the
90. Okay, for a change, 180. Okay. So to say at 90, you are getting this base curve.
yes.
So when you get a base curve here, it will fit well on the flatter meridian.
Yes.
This to create a plano tear lens. Why? Because this is parallel.
Uh-huh.
Correct?
Understood.
All right. However, on the 180th, because it's steeper, it will create clearance.
Yes.
Meaning to say, there's a space,
Yes. Clear lens sa
the
ilalim.
contact lens, and the cornea.
Uh-huh.
And this one will be filled with tears,
Yes.
the tear lens, correct? So, in actuality, you are getting rid of 45 by neutralizing the 45 steep because you are creating a tear lens
Ah.
of one diopter, thus making my 90 and 180 both at 44.
Okay. Makes sense.
Does that make sense? That's why you always fit flatter, always on the flat, always on the flat. Why? Because if you fit on the steep, what do you think will happen?
Uh,
Given that you have a flatter meridian and you fit it on the steep, what will happen?
magkakaroon ng ears sa gitna.
You will have a problem not only here, but also on the 90th. Correct?
Okay, got.
Do you understand that?
I
That's
think.
the principle. Because the principle is like this. Zach, remember my story about flooding? Assuming that the road has a lot of potholes, and this is EDSA for you. Oh, no, no, no. Going to CEU, a lot of potholes. But when there's flood, it became plain because everything is filled with
Water.
flood,
Flat.
water.
Okay. Yeah.
Correct. So in effect, when you are walking, and then all of a sudden you hit this very deep, probably manhole, you disappear. Oh yeah, right.
Yes,
Okay,
Doc.
that's why we work with tiers when it comes to RGP. So we always fit flatter. We fit on the flat surface because the flat will create that parallel. Then, for the steeper, the tear lens will neutralize the steepness of the cornea, thus making everything equal.
Wait, Doc. Sorry,
Thus
pero
make it neutral.
by a similar principle, wouldn't fitting the steeper meridian also create?
You steep. Okay, assuming that this is steeper, you
Wouldn't
already
that
know
also
this
fill in the
is steep.
flatter
So
meridian?
it's already steep.
Okay.
So meaning to say, what will happen to the flat? Supposedly, flat will create parallel.
Uh-uh.
On that note, you will even create, okay, take a look at this. Because my drawing is like messed up. hey, hey, the idea is always fit on the flattest, right?
Mhm.
Other one will be steep. Meaning to
Yes.
say deeper. It's gonna be
Yeah,
deeper.
it's gonna be deeper.
Oh, if it's deeper,
You can fill
this
it
will
up
be
with your.
compressed.
Okay.
You will compress the flat.
Okay, got it. Gotcha.
Got it?
That makes a
It's
bigger problem, yeah.
it's logic, my brother.
Okay. Gets the
All right.
doc.
Does that make sense to you?
Yes, it makes sense now.
All right. Yay! Very good, Zach. I love that question. But when you have Zach, when do you fit steeper? When you have keratoconus. Because you don't want to touch. What happened is, you don't want to touch the steepest portion. You create steeper fit. That's the only time we do steeper. But
Doc,
then again,
okay.
keratoconus is not good for RGP. That's why
Okay.
Era. Yeah?
So that's why you don't want to touch it because it's
Yes.
sensitive.
You don't. Because what happened? Exactly what you're trying to do. You will press this part
Mm-mm.
and it will damage more the cornea.
Damage more of the cornea. Okay. Yeah.
Yes. Does that make sense?
Yes, Doc.
Love the conversation, Zach. Love it. So let me check the others. Let me see. Okay. Very good. Uh, okay. Let's do that. There you go. Wonderful, guys. Good job, good job, good job. Okay, there you go. So are we clear now? Let's proceed to our continuation. Let's continue, shall we? Okay, so now we'll use the fitting guide. Remember, I asked you to memorize this. So now I will add this for the midterms. Guys, memorize this. It's easy anyway. Zach, I'll give you a tip. This is how I would work on it. I'll start by memorizing. As you can see, there's the middle part. Where's the middle part? That's the 9.4, 8.0. Can you see it? 9.4 OAD with an OZD of 8.0. You see that?
Yes, Doc.
Okay, so I'll come up with mnemonic. Say it with me. Flat, flat on K, steep. There you go. As simple as that. Flat, flat on K, steep. Meaning to say flatter than 50, flatter than 25 on K, and then steeper. Now you see that you can fit steeper. So if I memorize the middle with a flat, flat on K, steep, steep, by, because it's a bitoric, as you can see, what I'm gonna do now is go to my right, and that's a 9.8 and an 8.4 OZD. So as you can see, on my right is as simple as flat, flat, flat on K. Again, middle, flat, flat on K, steep. As simple as that. While on my right is flat, flat, flat on K. And then on my left is flat on K, steep, steep. And then bicurve or bitoric for everything. So meaning to say, Zach, if you have a cylinder, corneal cylinder of 0.25 to 75, this is what you should do. So when you alter or you have a base curve, this is what you're looking at. This is the OAD and OZD. You are to change the base curve, right? So you do flatter. Do you understand what I'm saying, Zach?
Yes.
Do you understand what I'm saying? All right. So, like, if you take again the middle, just memorize the middle. Start with the middle and then go left and right. So I have flat, flat on K, steep. I already know that. It's in my mind. Flat, flat on K, steep. It's a song, as a matter of fact. Flat, flat on K, steep. Okay? So if I have 0 to 75, 1 to 125, 150 to 175, 2 to 225, that is the amount of corneal astigmatism. So I would adjust my base curve accordingly. Okay? With my flat, flat on K, steep. Well, in any rate, as you can see there, this is for minus lens only. If plus lens, select a base curve, steeper. Everything is just steeper. So if I would go from the middle, I'm just gonna go flat on K, steep, steep. Because I'm going 50 diopter steeper. Correct?
Doc wouldn't be, ano, on K, steep, steep, steep.
Yeah, because it's 50.
Okay. Yeah,
K,
tama.
steep, steep. Correct. You're correct. Because it's by 50. All right. Very good. Good spot, Zach. Yeah, you spotted that. On point. Good.
Doc, so this philosophy is only for cylinder. So if spherical lang si patient, no need to think about this, right?
Zach, remember that the principle or the philosophy of RGP is here. Because
Mm.
the corneal astigmatism is always neutralized. By what?
By the Ano to? Sorry,
Clear
Doc. What's the question? By the clearance,
minus
right?
then. Of course.
Okay.
So you don't think of the cylinder whenever you use RGP because RGP only uses sphere and neutralizes the corneal astigmatism with the use of tear lens.
Yes.
That's why all your trial lenses are all sphere, correct?
Very cool.
Have you not noticed your lens? It's
Yeah,
all
okay,
sphere.
get it
It's
now.
all three. You don't have -3 combine this, combine that. You don't have that. What you have is nothing but sphere, correct? Is that clear now? Does that make sense?
Uh, I think I get it now, Doc.
You think you get it. So you don't know
Wait,
yet.
no. So okay. So let's say my patient is they have a corneal cylinder of like -5. So
Minus,
therefore,
-5, you say.
okay. So
Okay,
therefore,
okay,
sige, Doc.
okay, let's do it. Let's do it. -5. I'll do it. I'll do it. Okay. Corneal astigmatism. AC of -5.
Okay.
So what's the RX?
RX. Let's say -3 combined -5.
-3.
Ay, wait.
Combine
Hold on.
minus. Okay.
Sige.
Correct?
Uh-uh.
All right, very good.
It's really high.
What? Or not? What do you think?
Sorry, Doc.
Are you good with this or not? Is this good?
Doc, kasi
This
this
is what
wouldn't
you're
work
asking
for
me.
RGP, di ba?
This is what you're saying, right?
Wait, Doc, -0.5 na lang. Para mas
Huh?
ma-apply.
What?
Minus
No, no.
0.50 na lang.
You know what, Zach? This is very good. Why is this very good? Because this is an actual case of a patient.
Okay.
Other patient has this RX. My
Mhm.
question, what are you gonna do then? Anybody? Section A. Go represent. Tell Zach, what are you gonna do? If this is the case, this is the RX. This is the AC.
Doc, for this case, di ba, you can't...
This is purely corneal, correct?
Yeah, RGP isn't advised for this type of patient.
Why is it not advisable?
Because it's purely external.
Huh?
Hindi
Sorry?
ba? Or it's the astigmatism
Oh,
is too
Joseph
high.
will answer you. Oh, Joseph.
Magkakaroon po ng Rocky Fit pag ganyan po kataas yung...
Very good. What is a Rocky Fit? Zach, it's like
Hindi
this.
po siya
Okay, go ahead, Joseph. Go ahead. Go.
hindi po siya magiging stable po, Dok.
Very good. O, ano mangyayari pag hindi stable?
The vision of the patient parang magkakaroon ng swinging motion ganun po.
Doing emotion, other than that, this is already a failure. This is a major failure. So, Zach, what is happening? It will move a lot. It's like your cornea is already creating that triangle wherein whenever you close your eyes, it goes here and then it goes there. So it moved like rock, like Michael Jackson rock. Okay? Rock. It will rock. Thus creating a variation when it comes to vision. It's blurry all the time because it keeps on. If it swings here, it's blurry. If it swings there, it's blurry. So this is a total failure. Zach, so once you have a patient in the clinic and the RX is -5, it is now your judgment. Am I going to fit RGP on this patient? The
No.
answer, no. The answer is no. So there you go. Did I answer you, Zach?
Okay, sige.
Sige. Ano pa? Joseph, give yourself points. How much? +5. Okay. So Zach, what is it?
Hindi, Doc, I just wanted to see yung kaninang table applied, like, actually applied sa isang...
Let's go back to the table. This is the table.
yes,
As
yes,
you can, at 250, you are already in trouble.
Mhm.
Zach,
Ah,
at 50, you are already in trouble. Meaning to say, RGP may
it's not.
not be the good answer.
Okay.
Because what you need now is a bi-toric lens. Unfortunately, this is something that is difficult to manufacture.
Okay.
That's why the best thing to think of at this point, it starts with letter S.
Scleral lenses.
Yay! Finally! Zach, you know
Tumama
the
na.
answer. Now, once you see a patient at 250, don't give RGP, but give scleral RGP, not the corneal basic small RGP, but use a scleral RGP. So is scleral RGP? The answer is yes. Zach, the answer is yes. Or you can give a piggyback. What is a piggyback? This is what I will give the patient. Because I already have a -5, right? Correct? Zach, do you follow?
Yes, doc.
This -5 diopter seal already. I will place soft contact lens and then RGP on top of the soft contact lens. This is now a hybrid. Hybrid. Called piggyback. Piggyback. All right? If you don't want to give scleral and you want to utilize your soft contact lens and RGP, put them together. Create a hybrid. Or there is actually a design wherein the center is RGP and the skirt is soft. There is a design. And this is what you call the hybrid. Are we clear? Are we clear with the hybrid? So the hybrid is just like understanding that my periphery, since remember Joseph said it's going to be rocky, how am I going to address the rockiness? First question, Zach, will this neutralize the -5 based on your RX minus combined -5? Will this neutralize?
It would
The answer
create
is yes.
residual.
Yes.
Doc.
Because the center is RGP. The problem is gonna be rocky. That's why you put the skirt soft so that stability is achieved. Do you get what I'm saying? Joseph, is this clear?
Yes po, Doc.
Okay, remember Joseph, the problem when it's high, it's gonna be rocky. So how are you gonna deal with rockiness? Of course, you make the periphery adjust. So we call it toric periphery. Okay? Do you follow?
Paano
So
po i-adjust yung periphery, Doc?
by having a specialized design periphery. So the periphery will have an even measurement. It's like this. We'll discuss it in laboratory, but for the sake of section boy and dog, assuming that this is your contact lens. Oh, wait. I'll make it better. There you go. So here I'm okay, but my periphery, I'm gonna make it toric so that it will conform to the toricity or irregularity of my cornea. So here, it will fit And while this one will create a lot of tears, neutralizing that space. And this is why scleral was created. Because in scleral, you have solution in between your cornea and the contact lens. It's like a simple principle, Zach, creating flooding. Correct? And in the flood, what happens when there's flood? Everything is everything becomes even. Correct? It becomes a plane. Correct? So even if under the contact lens you have warpage, it doesn't really matter because as you can see on the surface, it's already plane. And there's a lot of solution under the contact lens. That is the principle of scleral lens. Isn't it amazing, Zach? It's amazing, right?
Yes, Doc.
Yeah. So always remember, whenever you think of contact lens, you think of contractors. Contractors. PWP. What do you call that again? Flooding. Correct? Correct? Zach, just a joke. Don't take me seriously.
Doc, issue ka, Doc, ha?
I'm just trying to be relevant. Okay? At least significant for the time being. Am I right? But does it make things easier for you? Do you understand it?
Yes.
Joseph, we're clear on this.
Yes, Doc.
Wonderful. All right. Okay. Time check, 7:54. We're just done with computation. So guys, it will be part of midterms. Please, Zach, what I suggest is you give yourself some, trial given numbers, work on it so that even though we don't meet, you have your problem solving. Okay? You do that. All right. We'll end at exactly 8. Let's end at 8. Okay. Fitting assessment, you have lens centration, lens movement, clarity of vision, lens comfort, and fluorescein pattern. One thing that is essential in RGP is always fluorescein pattern. Always remember that. Because we cannot evaluate the fitting unless we understand the tiers. Correct? Is that correct? Zach, do you still follow?
Yes, Doc.
Yes. Why the tiers? Why understand the tiers?
The tiers, ito yung ano, Doc, yung edge clearance, which basically gives you an idea of how good the fit of the contact lens is.
Okay. All right. Other than the edge, it's not just the edge. Why the tiers? The tiers are not only like it's tiers everywhere.
Doc,
Yes, go ahead.
para po makita kung how even the
Yo,
clearance is between the cornea and the contact lens.
very good, Zach. Joseph, another 5. Zach, do you understand that? What you're trying to analyze here is the curvature of your cornea. Why? Why would you know the curvature of your cornea? Because what is trapped is your tear. And by fluorescein, fluorescein, you would know whether this area is deeper because it's darker, and this is lighter because it's shallow, and then deeper again because it's darker, and then lighter because it's shallow. Do you understand that? Zach.
Yes, Doc.
Okay. So in RGP, static is okay. What is static in soft contact lens? Are they the same with RGP?
Ano po
Zach,
yung tanong, Doc?
the answer's already there. Yes, Joseph.
What's the
Are they
question
the same?
po, Doc?
What's the question? Remember static and dynamic? Do you guys
Yes.
remember static and dynamic? Okay. Is the static and dynamic the same in soft and RGP? Are they the same? Anybody? Are they the same? You already know whenever I'm asking, you, I always give you a clue.
Doc.
The answer is no, of course. They're not the same. That's why I keep on asking, is it really? Is it the same? The answer is not. Why is it not? No, they're not the same. Why are they not the same? What is the static in soft contact lens? And what is the static in RGP?
Doc, can I try?
Sure, of course, Angela. 10
In
points.
R
Okay.
in RGP, Doc, it's the alignment. In soft CL po, it's movement, I think.
Ah, very good. Can you elaborate? Can you explain further?
Sa soft CL po, kapag static, parang no movement po siya. Kapag po dynamic, may movement, nagra-ride up or down po.
Ah, very good. Very good. Okay. Anyone else? Anyone else has an answer other than Angela? Anyone? So, Angela, 5 points for Angela, Bea. Anyone else? What is the difference? When dealing with static, if I tell you the answer, I won't give the plus 10 anymore. No one remembers static? Oh my gosh. Who was your teacher in contact lens 1? I should punish him.
Doc.
Yeah. Yes.
Ay,
Zach,
ayoko na.
what, Zach?
Doc, kasi di ba when we're measuring static dati, we were measuring the distance or yung parang overlap from the cornea.
Okay, go.
Yung di ba, Doc, when looking for static is yung overlap. Ayoko na, Doc. Sige, sagutin niyo na.
May ibang gusto sumagot? Sige, who's the other one? You know the answer, for crying out loud. Who's your teacher, Zach?
Doc, 8 o'clock na! Sagutin niyo na, Doc!
Yes. All right, 8 o'clock na. Guys, the answer is in soft contact lens. Static does not involve blinking, while dynamic is with blinking. Remember, if it doesn't include blinking, that is static in soft contact lens. Did I teach that, Zach? My gosh, I'll go back to
Yes, Doc. Naturo niyo yan, Doc.
ha? Nakatulog?
Then,
Doc,
Doc, I said naturo niyo yan, Doc.
Naturo ko. Kasi nakatulog yata kaya na nakalimot.
Doc, hindi. Marami lang nangyari.
Oh, wow! Ang daming nangyari. Yun ang difference ng soft and RGP. Sa RGP, ang static is how the back surface aligns. Meaning to say, when you see whether it's flat, steep, or aligned, that is the static. To compare with dynamic, it's when the RGP is moving. That's the difference. May difference ba? Wala. Zach, may difference? Wala. Naku, nalito si Zach. Oh my gosh. Zach, oh my gosh. In soft contact lens, if it does not include blinking, that is static. As simple as that. If it includes or involves blinking, that is dynamic. In RGP, it's not about blinking. What is it about? It's the lens. If the lens is moving as to high riding, low riding, inferiorly, superiorly, laterally, nasally, temporally, this is dynamic. While static is whether it's aligned, flat, or steep. Do you understand what I'm saying, Zach? Zach.
Doc?
Yes. Who's this?
Doc, bali po sa static ng soft, ang chinecheck po doon is centration.
Okay.
And then yung
Remember-
static ng RGP is flat or steep or aligned.
Correct.
Okay.
Correct. So magkaiba siya. Kasi remember, pag sa soft contact lens, we ask the patient, look straight. Okay, blink, and we look at the movement. So every time we ask the patient to blink, we're looking at the movement of the contact lens. That is your dynamic. But if the patient looks nasally, looks temporally, and it is displaced, as long as it does not involve blinking, it is still static. That's why it's different. Right, Joseph?
Yes po, Doc.
Okay. Zach, is that clear? My man, is that clear?
Okay na, Doc.
Okay na. Ang hirap naman ng okay na. Dapat okay. Ulitin
Doc,
na.
pwede ko pa rin itong tanongin sa Saturday.
Hindi punta ka na lang sa klasiko. Sa Saturday.
Sige, Doc. Yun na lang.
Sige. Alright, good night everyone. It's a very productive. So,
Doc, wala ba akong plus points for participation?
I won't see you tomorrow, ha? What? Zach?
Doc, wala ba akong plus points for participation?
Of course, 10 points. Sabihin mo kay Randolph.
Agoy, yun.
Si
Thank
Joyce.
you.
Alright, goodbye guys. Good night. Agoy. Okay.
Thank you, Doc. Good night.
Bea, good night.
Thank you, Doc.
Good night, Doc.
Good night, Doc.
Thank you po,
Thank you
Doc.
po, Doc.
Thank you po,
Good night
Doc.
po,
Good night po.
Doc.
Good night.
Doc.
Goodbye. Good night.
Thank you, Doc.
Thank you, Zach. Maybe I should call Zach a different name. Theodore. Goodbye.